Right, there we go. Good morning, everyone, and welcome from a cold and wet Cape Town. It is the temperatures are certainly dropping here, so I hope everybody's keeping safe and warm. Today's session is particularly focused on the SNA 6 kilowatt installation requirements for introducing our off-grid model, the SNA 6 kilowatt installation. Now, remember that the installation guidelines are not specific for the SNA 6. They could be applied across our range to the 5 as well, and then obviously to the bigger range. It's just a way of mounting or connecting the cabling, which is different. You know, on our SNA series, everything is hardwired into connectors, whereas with the LXP 5 and the new 6, those are plug connected. So you pre-wire the plugs before plugging in, and then obviously the 10 and the 12 is hardwired into a bigger connection point. Right. Without any further ado, let's get started. All right. So basically, the content that we're going to be covering today is the installation site selection, system wiring display, battery connection, PV connection, AC connection, EPS load connection, generator, external PP, neutral potential earth bond introduction. That's something new for us because it's a new addition that we've got on our later model machines. You will see it. You would have seen it in the on the maintenance page. There is an enable and disable button for neutral potential earth bonding, but that does not apply to the 5 kilowatt machines that we've got in stock that we are currently selling. We've got to wait for those to sell out before we bring in the ones with the bonding relay. But the new 6s, we brought in a limited amount of, I think there were 200 machines that were brought into the country. And those are already all sold and are out and installed. Those machines do come with the bonding relay, so you can make use of that. Okay, right. So let's have a look at the typical type of installation that you're going to be doing. SNA is IP rated, right? It is not an IP65 like the LXP series, so you've got to be very, very careful on how and where you install it. First of all, coastal regions, not a favorite for the LXP. For the SNA. The reason being is the high humidity, the salt content in the air. It's definitely not the environment that we like to see our machine installed in, and certainly in our warranty documents, the updated ones, there will be a limitation on the location of the installation from the sea. So just avoid high salt and humidity areas. Consider additional lightning protection. And then we're going to get into that in a second, but I want to focus more on this installation in a high salt and humidity areas. It's going to speed up the corrosion. We see it on the fan plate. Even though the fan plate is galvanized steel, we still pick it up on there. And also on inside on the PVC shrouds that guide the fan air through the machine. We also pick up a lot of condensation inside those machines, and obviously that mixes with the dust particles that comes through, and it forms, it has like a constant moist environment, and it's not good. We can, I can show you some horror stories of what machines look like when they come back from areas like that. So make sure that you are going to avoid these areas. If the installation is in a high moisture area, you've got one of two options. I know the SNA is the price point machine, so you obviously we're selling it in an environment that is very price sensitive. So either the client has got to go for the LXP series, which is IP65 and completely sealed, or the environment that you install the machine, like the photograph in the background here, you can see it's quite a neat little room. It has a cover on it, a roof cover, and obviously the installer will make sure that the room is dry and less humid. Okay, the other thing that we're also going to be avoiding is a dusty environment. The machine comes, if you have a look at this photograph here, you'll see on the side here and underneath the machine, there are dust covers that are pre-installed. You've got to make sure that those are in place, and especially encourage your clients to regularly unscrew them. There's a little foam sheet inside there. It's expanded foam. Just take it out, give it a wash, give it a blow, compress the air, and clean out the dust, put it back in. It certainly increases the ventilation through the machine. But those foam filters are critical for keeping dust particles out of the inside of the machine, right? If you are in a particularly dusty environment, I've seen machines installed in workshops where the guys are either spray painting, or we've had a very interesting one where the guy was doing woodworking in his garage. Needless to say, these filters did not suffice, and they had to put an extra dust net over the machine to prevent ingress of dust. And then one of the things that we highly recommend, especially for you guys up there in Johannesburg, where you have a high incidence of weather like lightning and even convection lightning, you have to install SPDs or surge protection devices before the machine. So here you can see that it says we have built-in secondary lightning protection inside the machine, but that is, that's not your. This doesn't mean that you can eliminate it from your installation. A good installer will include the surge protection device on both the DC and the AC side of his installation, because you're protecting the customer's investment. We do have lightning protection inside the machine, but not in the form of an SPD. These are metal oxide resistors. And we have 5 of them inside there on each input. So we do our best to protect the machine, but it's not that's the last bastion of support. And trust me, we still get surges that go beyond those. We are investigating different options, but I highly recommend, as a matter of fact, we might even insist that you put in AC surge protection as well as DC surge protection system design. Okay, so here we have a typical schematic of what the design would look like. So starting on the left-hand side here, we've got the grid coming in. The schematic is slightly wrong because it has both the live and the neutral going through the grid CT. Only the live goes through there, okay? So the neutral will go through here. The SNA 6 is shipped standard with an external CT. And it's not, unlike the LXP range, it's not mandatory that you fit the external CT. But if you want to export grid and have the machine compliant with your municipal application, then you're going to have to fit the CT. So it'll be on the positive, on the live incoming before the main breaker. There is an arrow on the CT which shows the direction of flow of current, right? So it's always from the grid to the load. That's how it should be installed. And if you do make a mistake with that, you can always reverse on the maintenance page. We do give you an option to reverse the direction of the CT if you've installed it incorrectly. Okay, so let's have a look here. So we've got the grid here, we've got the CT coming to your main breaker, and then it goes to your load panel, right? And then from there, you're going to have your non-essential loads here. Then you have an SPD and circuit breaker feeding the AC in the LXP, to the SNA. And then from here, it's going to go out to your secondary panel. We just didn't have space on the diagram to put another panel here, but typically you would have another panel here. And one of the things I want to point out to you is you will notice that the supply to the SNA is before your earth leakage or your residual current breaker, all right? So you do not feed this machine through an ELCB or an earth leakage circuit breaker, because you will get nuisance tripping. So it's a raw feed in through an ACSP circuit breaker, a rated circuit breaker, and we'll discuss that in the next set of notes. And then from here, you have your loads going out, your essential load. Here you have your generator input. You'll see that the generator input breaker is also rated 60 amps. The load breaker on the 6 kilowatt on the EPS side is 40. And here we've got 60 amps going in. The reason we ask for 60 amps is because you must remember that this machine and all of our machines have a bypass relay in there, which means that the power can come in through the machine without going through the inversion, and it'll bypass directly to load. So it means that you can exceed the capacity of 6 kilowatts on this machine on bypass current, right? So we'll go through the specification on that a little bit later. So always be mindful of the fact whatever load you connect on this side can exceed the capacity of the machine on bypass. But when it's inverting, in other words, when it's running in off-grid mode or supplying these loads from battery and PV, then the limitation will be 6 kilowatts. Okay, so there you've got your loads, your non-essential, your non-essentials, essentials, and your generator with the suitable circuit breakers connected. And then on this side, we have the DC side. Here we have the PV. Once again, PV comes in through a SPD, a DC SPD, as well as a set of fuses and circuit breaker to the PV input, and then the battery exactly the same through a rated circuit breaker, double pole to the machine. You can use either a circuit breaker or the blade fuses, whichever suits you, but it has to be rated according to the requirements of the machine. Right, so the next step we're going to look at is the battery connection. Okay, so the equipment features built-in secondary lightning protection, as I mentioned, but we still have to take care that we do our DC side correctly. So here on this side here, you can see that we've got a stack of HANA batteries going to one machine. Take note, see where the positive goes into the top and the negative goes all the way to the bottom. So we've created a loop here in the DC. It's ideal for the balancing of the batteries. If you had connected both your positive and your negative to the top and then simply parallel these down, there's nothing wrong with that other than the fact that you will definitely get unbalanced batteries lower down in the train if you have a bigger battery bank. So we always recommend that you do you wire your batteries in this manner, positive to the top, negative to the bottom, or the other way around. As you know, I always make the joke that DC flows like your favorite band in one direction. Okay, so I'll always flow from a high potential to a low potential. And this is why we loop it like this, so that we have the current flowing across all of the battery packs. These cables here have to be adequately rated. Remember that standard cables that come with the battery are typically 125 millimeter. That's the square diameter of the machine so it's 125 mils. That's 25 mil square. So you get 25, you get 35. The 25 mil square is rated for DC up to 120 or 125 amps. And some of you will have experience on that where you notice that the cables become quite soft when running at that current. Now remember that the SNA 6 has a much higher charging and discharging current than the 5. So 25 mil will not suffice. You're going to have to go up to a 35 mil cable for your battery pack. All right. And then in this diagram here, we've obviously omitted the fuses and the switch here, but we've discussed that in the previous diagram. Okay, so the device supports maximum charging and discharging current of 140 amps. So you're going to have to put a minimum of 35 mil cable in for your DC, and it's recommended to select the appropriate switch model based on the battery's maximum charging and discharge current. So we recommend choosing a circuit breaker that is rated, obviously 140 amps is going to be the minimum entry requirement for your breaker or your fuse. But if you go for a 200 amp breaker, it far exceeds the system's capacity for one inverter. And obviously, it gives you peace of mind as well as your customer or your end user. When connecting the battery, please refer to the pin layout. Often in our support center, we get requests for what is the pin layout for the various batteries. And also, there are a lot of batteries on the market now that are rebrands or brands that we haven't tested. When you're using a battery like that, remember that the onus is on you, the installer, to make sure that the communication, you'll be responsible for the communication if it's not on our list. So the pin layouts for our inverter, we can do RS485 as well as CAN, and we'll go through the pin layout in a second, okay? But doing the communication, it helps ensure good compatibility and communication between the device and the battery, and it also ensures the system operates stably. We have had incidences with certain battery manufacturers where we have what's called SOC drift, where the SOC is showing one value, but the voltage is another. The batteries might be fully charged or at their fully charged capacity, but the SOC seems to be degrading every day. And that typically gets fixed with a intervention by the battery manufacturer through a firmware update or system reset or something like that. One thing I want to point out to you guys is that when you have a look at the screen of the if you look here on the screen of the SNA, the information that is shown here, especially on the battery side, if you're using battery communication as well as on the monitoring side, that information is information that we get via the communication cable from the battery BMS, okay? It's not information that the inverter is calculating and putting up there. Unless, of course, it's a lead acid setup, then we do a calculation. All right, when using the built-in switch to control the battery, it's advisable to avoid individually operating individual batteries during high power charging and discharging to prevent overcurrent. Okay, so basically what we mean by that is that do not switch your batteries on and off individually if the inverter is either discharging or charging the batteries, because there's high current flowing through these cables. And especially if you're pulling fuses, that's a very big spark that you're going to have to control this. So always make sure that your inverter is in standby mode and the batteries are neither being charged or discharged before you make and break connection. Okay. Right. So this particular diagram talks to us about the communication cable on the inverter side. This is the inverter CAN port. Pin 1 and 2 is actually 485. So we have 485 on pin 1 and 485B on pin 1 and 485A on pin 2. And then on pin 4, our pin 4 out is CAN high, and our pin 5 out is CAN low. Remember, on the older version of the machines, the red tip machines from last year and the year before, we had CAN low on pin 3. So we've standardized ours now to go with what the majority of the market is, and that is pin 4 is CAN high and pin 5 is CAN low. So it's a straight through cable, okay? Some of you might have trouble with the pylon tech. Remember that pylon, especially the UP5000, you cannot have all 8 pins connected at the same time because it doesn't like 4/8. I know you use the phrase doesn't like, I mean, like it's a human thing, but it doesn't work with 485 and CAN on the same cable. If you're using pylon, especially the UP5000, just make sure that you cut wire 1 and 2, which is the 485, before putting it into your into the inverter. Then we will get solid communication through our CAN bus communication, okay? And then on the battery side, I mean, we're just referring here to the HANA battery. Pin 4 is also CAN high, pin 5 is CAN low, so it takes it straight through cable. It works great. Right, so our example this here uses the HANA battery, and it's got the compatible battery models, obviously the Hi-5, the PowerGem, and the PowerGem Plus. The PowerGem Plus is our new model that we introduced this year. It's a 14.3 kilowatt-hour battery. A nice chunky 280 amp hour high G prismatic cell in there with a 0.5 C discharge, which gives you about 7.2 kilowatts max continuous. Okay, right, shared batteries. Many of you have got experience with this. So the shared battery we use when we typically have more than one inverter. So it's either 2 or 3 in either a single phase or a 3-phase configuration. And it doesn't really matter if you've got one machine on one phase and 3 on another and another, you know, like unbalanced, we can do that. But we always recommend that you share the battery. And here you will share the battery through a common bus bar. The bus bar is not drawn on here, but ideally all the inverters will have access to the battery bank. And the reason we recommend this is that a shared battery bank can better balance the load and it extends the life of the battery, improving the overall stability and reliability of the battery. Because remember, imagine you had one battery on each one of these. okay, then we would, you cannot select shared battery. Each machine will charge and discharge its battery at will. And then in the end, your client might end up with a battery bank where you have batteries of varying state of health, varying cycle GT, and some things like that. So if you connected them in parallel, the batteries in parallel, you created a master and slaves bus bar, and then a master and slave on your, or subordinates on your inverters. And it simply means that it will cycle all of the batteries at the same time. You know, you shouldn't end up with unbalanced batteries, unless, of course, you add it to a battery bank at a later stage. Okay, so it increases the energy utilization. The batteries, it allows multiple users, inverters to use the same battery. And this is especially typical on a three-phase. Imagine this was a three-phase installation, and you had a battery bank here, and this is your red phase, the blue phase, and the yellow phase. Imagine the blue and the red were the blue and the white phase were idling. In other words, there was no load there, but there was a lot of load here in an off-grid situation. It means that this inverter will have access to the full battery bank. And that's why we always recommend that you do battery sharing. It works great. And so, yeah, let's move on to the next one. PV connection. I'm going to have to spend some time here. Let's go. All right, so as you know, when you set up your machine, you will notice that there are three input modes. The first input mode on your settings is DC source mode. Now, DC source mode is typically used for us in the lab or for testing, where we're going to, in other words, we have a stable or flat supply of power coming in on the DC. So in other words, the system doesn't have to do any tracking. So when we do testing in the lab or at the R&D facility, they will normally set it to DC power supply because it's a stable or a flat line of DC coming in. That's the only time you will use that. Don't use that when you're doing PV, because with PV, we have to select one of the two tracking profiles. One is either parallel strings, and we're going to go through that in a second, or independent strings. And the MPPT, for those of you who don't know, it stands for maximum power point tracking. Okay, so the logic on there always allows it to track the maximum power point. All right, so we can have identical string input or the same string, or we can have independent string inputs, okay? Now remember that we've got three criteria that we have to meet, and it has to meet one of the three, okay? You cannot exceed any one of them in any circumstance. So remember, let's go here to the select this one. Okay, here you can see that we have the specific, this is the spec sheet for the SNA, right? And here we have the 6 kilowatt. If you have a look here, the maximum PV array power is 8 kilowatts. That's the maximum that the MPPT can take. Remember, our machine has 2 inputs, so that'll be 4 kilowatts per input. When we say we have 3 criteria to meet, it's one of these. You cannot exceed 4 kilowatts per input. You also cannot exceed the voltage input, and you cannot exceed the current input. Okay, so we're going to focus here for current. We're going to focus on the 17 amps. For voltage, we have 2, and I will discuss this with you briefly. We have 480 and 385, and then for the strings, we have 4,000. Now remember, you cannot exceed any one of these in any configuration. So let's start with the independence. So we have an inverter that has got 2 independent strings. You've got string A and string B. In no instance can you, in your combined power, remember that solar panels are installed in series, all right? So if you're putting up a 500 watt panel, so it'll be 4,000 divided by 500. That means 8 panels per string. But the next thing we need to do, so now we know that we cannot go on 4,000 watts per input, we can't exceed 8. Then we look at the open circuit voltage rating of the panel, right? That will be on the information sticker which comes with the panel. And it might be a 48 volt or 52 volt, depending on how many cells it is. You know, you get 72 cell, you get the old 60 cell, and even now we get the 144 split cell. So you have a look at the VOC. That is open circuit voltage. So I'm sure you guys understand what open circuit voltage means. It means exactly that. So if you took a solar panel and you put the panel, you use my calculator, that's the panel, right? If you put the panel in the sun, it's exposed to the sun, it will have a positive connector and a negative connector. If there is no resistance across here, in other words, they're not connected to a load, then that's open circuit voltage. The minute you connect this to load, in other words, it goes through a charge controller or something, and there's resistance across these two, what will happen? The voltage will drop. The current will go up and the voltage will come down. So this is open circuit voltage. In other words, with no load connected, it should be that. But with load connected, you cannot exceed 385 volts. The chances of you getting to 385 with 8 panels connected under load is highly unlikely. But we've seen cases where guys do that because they exceed the number of panels here. They're not focusing on, you can't in any instance exceed any one of these, right? For our example, we're going to be using 8 500 watt panels with a 50 volt open circuit. 8 times 5 is 400. The 400 means that we save here. And it also means that, and then if we have a look at the short circuit current, or the maximum, here you can see that the short circuit current will be 17 amps, or sorry, on the panel it might be 13 amps. So which means 13 is less than 17, 400 is less than 480, and the 4,000 is on the limit. That's good. The other thing that I also like to remind installers is that by going for the maximum of 4,000 watts per string, going to give you 8,000 watts input. But remember that our inverter is only a 6 kilowatt inverter or 6,000 watt inverter. What happens to the other 2,000 watts? It will only be used, number one, when the battery requires charging or additional charging and you have load. So you've got to have loads of 6 kilowatts and a charge requirement, then it'll exceed the 6 kilowatts. Or alternatively, you might have low solar radiance days like today, when it's handy to have this size array on your roof, because you've got more exposure, and you might not get 8,000, but it gives you more exposure to get a higher yield for the day. Always remember that solar panels are temperature dependent. Their yield is temperature dependent. So if you have a bright, clear day, like we will definitely get that now in winter, and the temperature has dropped. If you get a temperature drop either with cold wind blowing over the panels or the ambient temperature because it's been snowing or there's a cold wind in the air and the temperature of the panels drop, then the yield will increase. This is why there are limitations here, that we cannot exceed these, okay? Very, very important. Otherwise, you will end up damaging your panels. We do have a 25 amp maximum short circuit current, but the critical thing here is short circuit, okay? It's not load, it's short circuit for a very, very short period of time. We've seen some MPPTs come in here looking like they've been in a house fire. Okay, while I've got this open, let's just have a look at battery types. The battery types are lithium and lead acid. Now, lead acid is obviously old terminology, so we should actually just change it to voltage control, because there are guys that are using batteries that are not on our list, or you're still using the old gel batteries, or you might be using an old lead acid battery. It can accept any one of the nominal voltage range is 48 volt. Obviously, we can operate from 38 volt up 60 volt. All right. For you guys that are installers, and especially for distributors that are monitoring and offering tech support, you will notice that on the maintenance, not on the maintenance page, the data history page, if you scroll across in all of the information that you get in one of the columns, there are 2 columns that shows you the V bus voltage. V bus 1 is DC from the battery, and VBus 2 is DC from the PV array, okay? So typically we're looking for 7 times the voltage of the battery on VBus 1 in the 6 kilowatt. If it's a 50-volt battery, then we're looking for about 350 volts on the VBus 1. That's just some extra information. Okay, so the battery voltage range from 38 to 60. You want to keep it under that. A lot of the 16-cell batteries now are charging at about 57.6, especially the HANA battery. The maximum charging voltage is 57.6 or 4 volts, I forget. So we have capacity here, right? The max charging, so we're going to look here under the column for the 6 kilowatt. The max charging is 125 amps. Max discharging is 140 amps. So if we work on 52 volts times 140, that's going to give us 7.2 kilowatts. Now, 7.2 kilowatts obviously exceeds the capacity of the battery, but we could have 140 amps at 48 volts or 46 volts. So that's why we have these capacities here. The max charging and discharging power is 6 kilowatts. And very soon we're going to go back to the diagram because we need to talk about this charging capacity, especially on your AC side, right? And the recommended battery capacity for each inverter, 200 amp hours. Okay, so let's go back to the PowerPoint. Hang on, I think let's just go see if we. Okay. All right. So on the PV side, remember we spoke about we can have installations where we can have string. So here we're looking at a string that is series, right? So this is one string. Here we have 4 panels. In this example, the panel is 250 watts. The 4 of them gives us 1,000 watts. The open circuit voltage is 152 volts, and it's 8 amps. Remember that when you series, voltage goes up, amps stay the same. Okay. So in a case like this, we're looking at our MPPT supports 2 independent inputs, and we went through that previously. We spoke about each one can do 4,000. We do sometimes get calls asking, is it 4,000 total or 4,000 for the 2? In the case of the independents, it's 4,000 watts per input. You've got to stay under 380 volts, and you've also got to stay under 17 amps. Okay. What happens when we go to parallel strings? You can see here, we've got here in this instance, you've got a parallel string there. You've got a series string there, the series string there. And then what they've done is they've paralleled the 2 positives and they've paralleled the 2 negatives. Then they bring it into the inverter. Oh, sorry, this is wrong here. It should be 4,000, but your limitation there will still be 17 amps. But on a parallel string, this is in an instance where you have panels that are low current, as well as, because you must remember that in parallel situation, the voltage stays the same, but the amps double up, right? But if you were using, for instance, a panel, maybe a 300 watt panel or 320 watt panel with a 9 amp rating, or even smaller one like a 250 volt panel with 8 amp rating, then you can parallel them like this. It will take the current, incoming current to 16 amps, and the voltage will stay the same. Then you can bring down one set of cables from the roof, and you can run it into the MPPT. If it exceeds the power, you can always bridge the power out. But we always recommend that you stick to the limitation of 17 amps and 4 kilowatts. You can then make sure that the cables that come down are rated for the current as well as the voltage. And then also on the selection, on the settings, you're going to set 2 panels, same string. Okay. Right, so let's go to the AC connection. AC connection, make sure that the AC polarity wires are correct. Okay, so we do have protection for reverse connection, but obviously you've got to be sure that you get this right, because on your connection you're going to be using a neutral bar, so you can't put a live on there. It'll be quite a nasty little short circuit, and a mistake that you only do once. All right, so what we do is we recommend the right size cable for the application, especially cable that is rated to carry power throughput. Now remember that the throughput power on the SNA 6, I think the rating is 50 amps AC, and we can check that on the spec sheet. So it's always recommended that you use the cable, especially from the AC side, through the circuit breaker into the AC in, excuse me, that is rated to carry the bypass current. Even if you're limiting your output current to 25 or 30 amps, your supply power still has to be, the cable still has to be able to carry the correct current, because when you are AC charging and taking load at the same time through the AC cable, then the cable must be rated to carry the right amount of current. Otherwise, you're going to get of the cabling, and obviously you're going to compromise the circuit breaker and the connection point. So please make sure that you use the right size cable. So we obviously recommend that you remove the insulation. I mean, it's common sense, and ferrule them. But our guideline or the standard that we always go back to is not our recommendation, but the SANS code. So SANS code is the law by which we in South Africa have to abide by. And what we give you are merely recommendations for how we need to see you do the installation. The other thing that you're also going to be very mindful of is your warranty. So stick to our guidelines as well as the NRS certification, all right? And then this is also a typical one here. Just make sure that your AC wires are securely connected. It's very, very, very important. All right, here we have a diagram of the inverter. Okay, so we always recommend, in this particular diagram here, you've got grid, you've got your EPS or your essential load, and then you've got the generator input. Yeah. So we always recommend that you fit in a changeover switch, all right? Because the changeover will allow you to take loads from the grid and bypass the inverter directly to the load in the case that you need to service the inverter. Okay, so this AWG stands for American Wire Gauge, and that is AWG I think it's a 6 millimeter square cable. All right, but obviously you can go up to it. Bear in mind that cables have rated resistance or internal resistance. Especially if you're doing more than one machine in parallel, you've got to be mindful of the size of cable that you're using, not only for the current carrying capacity, but also for the internal resistance. Okay, remember Ohm's law, V equals IR. All right, so here we have on this diagram, we have the grid coming in, goes through the changeover switch, or a double pole, single pole, a double pole, single throw, or double throw, single pole. Yeah, make before break changeover switch. Then you obviously have your circuit breaker. It goes into the input of the machine. Your output comes out, goes through a rated breaker as well, feeds the changeover, and then goes to load. And here you have your generator coming through dedicated circuit breaker. Okay, the gen input, regardless of the size of inverter that you put, generator that you put on the SNA 6, we have a limitation here of 7.2 kilowatts. In other words, it will never exceed 7.2 kilowatts input. Even if you had a 20 kilowatt generator feeding the inverter, the rated capacity here is 60 amps. It will never exceed that. Okay, and then here we have our PV input. And obviously, as discussed previously, we're going to go through surge protection device, fuses, fuse holders, and the circuit breaker, DC breaker. And then this is obviously your battery bank here with a dedicated rated circuit breaker, minimum 140 amps. Okay. Right, on the EPS connection side, on the load connection side, a separate port for essential loads ensures that the critical household appliances continue to operate during a power outage. You guys know that. It's very common here in South Africa. You know, load shedding taught us that. And this is where the machine became very, very popular, is the fact that it could operate as either as a UPS or as a PV power supply. And we've now included extra features on here, which I'm going to go through with you. But this is, once again, just a typical diagram of what the layout look like. So here you've got your meter coming in, mains breaker, there's the CT. It goes into the AC in, and then it goes to the changeover, right? And then from the output, we have our residual current breaker here, or the ELCB, or earth leakage circuit breaker. And remember that we have, the only thing that we common is the earth bar, right? We don't, this neutral and this neutral will never see each other. These neutrals are always separated. So here we have a typical layout. And just remember that the maximum output power of the EPS is 6 kVA, right? If it exceeds 6 kVA, then the following actions will occur. There will be an overload prompt at 1.1 times the rated capacity. If the load exceeds 1.1 times, or in other words, 6.6 kilowatts, for 10 seconds, or exceeds 1.5 times the rated capacity for 5 seconds, or exceeds double the capacity, in other words, 12 kilowatts. We'll see that on a motor or a pump startup. We have a surge current coming through, it can handle that. 5 seconds, then the load will be cut off and you'll get an EPS overload. Okay, so remember that. We do allow for these rating times for startups. All right, the generator port or the generator connection. There's a dedicated generator interface which allows for a quick switch to generator mode in the event of a power outage, ensuring seamless off-grid functionality. All right, so underneath the machine here, the machine's been flipped over on its back, and this is what it looks like from the bottom. So here we have the gen port, and typically you will have your live and your neutral going in here from the generator. Now remember that your generator input, we discussed this previously, regardless of the size of the generator exceeding 6 kilowatts, the maximum power that the inverter will draw from it at any given time is 7.2 kilowatts. And that is to take the load and charge the batteries. In the old SNA that we currently got in the market, especially the 5 kilowatts, the generator was dedicated to charging the batteries as well as taking the load at the same time. So if you had PV connected, the PV would only charge batteries, it would never take load. The generator had to carry the load capacity as well as charge the batteries. That's why we always recommend you size your generator to 1.25 times the size of the inverter. So in a 5 kilowatt, it would obviously be a 8. And we've got limitations here. You can also use an 8 kilowatt on the 6 kilowatt. But if you're paralleling more than one, then obviously you have to have a exponentially bigger generator to handle that. All right, so in the point number 1 here that we're going to talk about is support for dry contact and remote start. Here we have dry contacts, and you will be able to see them on the connector ports. Dry contact allows you to remote start a generator that has an automatic start, an ATS. An automatic start function. ATS is an automatic transfer switch. It has an automatic start. It will work on the maintenance page. There's a setting for generator, and it will work either on it has 2 flags. So if you've selected voltage, then it will use the lower voltage to start the generator and the higher voltage to switch it off. If you choose SOC, it will choose the lower SOC to start the generator and the higher SOC to stop the generator. Remember that we can only stop and start the generator. These are relays, right? So we have a normally open relay and we have a normally closed one. They share a common port. You're on the dry contact, it will be normally closed, common, and normally open. So one will be normally closed and one will be open. And when it gets to the flag, they will switch roles. And that's typically how it starts the generator. It's literally just a switch. Okay, there's no power coming from the generator to anywhere. You can run voltage through there, or if you're using it to power a relay or something like that, you can run voltage through there. It's the limit. You can either run because it's a single line or single pole. You can either run AC or DC through there, but there are limitations as to how much switching current it can take. I think the maximum switching current it can take is 5 amps. And in number 2, we're going to talk about smart load and AC coupling functionality. This is a very cool feature for the SNA. Smart load simply means that if you are not using the generator port to feed the generator in, you can allocate it to a generator a smart load output port. It means that when the generator is not connected, you can turn that generator port into an auxiliary port. So if there is sufficient on the settings page, you will see smart load settings. So if there's you tell it when there's sufficient solar and when there's sufficient battery SOC. You give it the flags on when to start, when to stop. If it's load shedding and there's solar and there's enough battery, it will put out power on the AC power output here, as well as the generator output as an auxiliary output. 2 things to remember. I don't know why I said 1, but it's 2. 2 things to remember. The combined output where's my mouth? The combined output for this one and this one is 6 kilowatt. Can't have 6 here and 3 there. It doesn't work. Right, so combined output is 6 kilowatts. That's number 1. And number 2, you cannot enable load with the generator connected here. Okay, you will send your generator to the scrap heap in a very short space of time. So don't do that. Be very careful because it's going to push power up here. Okay. So this enhances the overall efficiency and flexibility of the system, making an energy management more intelligent and more efficient. Okay. And then point number 3, we can support for generator bypass load and generator charging. But the system supports load operation in generator bypass mode and can also use the generator to charge the battery. The maximum current for the input relay is 60 amps. Remember, we spoke about that earlier. The maximum power that you can put in here is 60 amps DC, load and charge the batteries. And then point number 4 is a very cool feature that we've just added to the 6 kilowatts. As a matter of fact, we've got it on our other machines as well. It's called an N boost function. Now, previously, when we ran a generator, our relay from the DC side on the PV was disabled to supply load, purely because we didn't want any leak current going to the generator, for obvious reasons, damaging the generator. But now we have what's called an N boost function, and you can enable it. As an installer, you have the power to enable it. What does it do? If you are running a generator and there is PV available and the generator is underpowered, for instance, you might have a 2 kilowatt or 3 kilowatt generator and you've got PV available, you can enable the boost function. What this inverter will do is it will use PV to assist charging the battery and take load. Very cool feature. I highly recommend you try it if you have that requirement. Okay, so remember that when you're using a generator, if the generator cannot be operated by the dry contact, then you'll need to manually shut it down after the grid power is restored. Okay, so typically here's a flow diagram of what we would look at. If there's a power outage, your inverter will go to off-grid mode. If you discover that like for instance, now we've got terrible weather and we've had bad weather for days, there's no PV harvesting, and you notice if you're running an off-grid situation and you notice that your battery capacity is running down, you have to manually start the generator. Some of the questions that we've seen is, my generator is running, but there's no power going through to the loads and charging. It's because our system or our inverter will monitor the power input. So your generator voltage regulator has to be running or serviced or working properly, because we're looking for a voltage range and we're looking for a frequency range. I saw somebody commenting this morning that the generator is running, is putting out 212 volts and 42 hertz. And they can't see anything on the AC, on the generator input. Obviously, it's not going, the relay won't open because the frequency is too low. Remember that when the generator is running through there, the inverter doesn't modify the sine wave of the generator input, it copies it. So it's got to be clean power coming in, because that power has to run the load as well as run our AC side on the inverter, convert it to DC to charge the battery. And then when the grid returns, it will open the grid relay, close the generator relay, but it won't switch the generator off. So remember, this is for manually stopping and starting a generator. You physically got to go to the generator and shut it down. That's in manually started and stopped generators, okay? Right, so operation diagram of the off-grid situation. So this is off-grid for a generator. So here you can see the client's got PV, he's got batteries, he's got a generator. Okay, so the generator he's got going to the gen input. Single inverter allows for a maximum input of 7.3 kilowatts. So we recommend selecting the generator capacity based on the system's maximum allowable input power. Lux has recently released. We've released the boost feature, remember, which allows the PV to assist the battery to supplement the power. And it's a very good feature. I like it. I like it a lot. Right, here we have a generator working with single phase parallel. So you can see the PV coming in. We have 3 machines in parallel. We have the generator coming in, and the generator is adequately sized because this one is feeding all 3 inverters. Okay, so this is the ideal situation. You have a generator feeding all 3, and you have your normal loads running here before it gets to the inverter. And this is quite cool to have, especially if you have a generator that's battling to get its voltage correct. You can always connect an external load before it gets to the inverter, like a small load, like a heat from the generator. And this is, like I said to you, this is an ideal situation, okay, where the generator is sized accordingly to supply all 3 inverters. Another interesting thing to know, remember Ohm's law is going to apply here as well, right? Remember Ohm, V equals IR. So here we will always have internal resistance. If you have one inverter, a generator, then the resistance input is lower. But if you have 2, it obviously increases, and 3, it increases exponentially. And that's going to change the dynamics of your charging and discharging. So just remember that in a multiple parallel environment, you have internal resistance between inverters. Okay, so this layout here is very important. The routing of the cabling, the inverters. You know, if you're going to be doing this and then stringing like that, you might want to consider your wiring correctly so that you get the resistance accurate across all 3. Otherwise, you'll have input voltage differences on your inverters. And we have a look at the infographic for your 3-phase parallel, exactly the same as the single phase, but obviously the difference here is the power routing. Here we have a 3-phase generator going through your 3-phase breaker, and then each inverter will get a phase. Okay, so there's the red phase, there's the yellow phase, there's the blue phase. And once again, the generator is adequately sized to take load and charge the batteries. But bearing in mind, our new feature now will also allow for generator boost with PV. By the way, any one of these schematics are available to you guys if you want. You can always request it from our marketing department. We are very happy to share it with you. It's just a guideline. Remember that our dividing line, or the rule that we stick to, is the SANS code, right? 10142. latest edition. Okay, external CT connection. Remember, the SNA 6 comes with a CT, the 5 does not. The 6 comes with an external CT, and it's optional to use it. You obviously have to use it if you're going to be grid connecting and you want to export. Then it is a requirement, especially here in Cape Town. This is a City of Cape Town requirement that you have an external CT connected, and you have to mark that on your application when you're doing the application. Like our LXP series, where the CTs are compulsory, with the SNA, it's not compulsory, because we do have an enable and disable function on the settings page where you can enable the external CT. All right, so this is what the CT looks like. The ones that we've supplied recently are blue in color, and you can see it's got an arrow on there. See that direction arrow? Your live will go through here, and the flow will be, the arrow will point to the inverter. So it's from grid to the inverter. You see here, the arrow is always pointing in that direction. And if you've got it wrong, you can always go into the settings page and switch the direction of the CT if you've installed it incorrectly, because trust me, sometimes it's a real bother getting into a very dense DB to try and get your fingers in there and turn a CT around. Okay. All right, so the CT wiring, typically the CT only comes with 2 wires, which we use here. It's 5 and 6. And you can cut the CT and lengthen the cable, just color match the wires inside. It's only 2, it's a 2-wire cable that we supply with it. And you should get, I know in the LXP range, we do fit in a little, we fit in a connector kit for the CT if you're going to lengthen the CT, but please make sure that you match up the wires. It's not just the simple case of connecting the wires. Sometimes it's a blue and a green wire, or green and brown. Make sure you go green to green, brown to brown, okay, when you extend the cables. Okay, so this is the what the output screen looks like, and there is your CT, the installation for CT. But here you can see you can enable, it says grid CT connection. You can enable it if you're going to install the CT on the 6 kilowatt. This button here is obviously for PV and AC to take loads jointly. That's the hybrid function. And then if you are exporting to grid, you're going to enable it. And then it also going to ask you what your export power percentage is. And if you want to know what that is, just hover over the blue question mark here. That little pop will come up on your screen on the web portal, and it'll tell you what it is. It's basically just the excess power that it's exporting after charging the batteries and providing load. So remember, it can provide load to charge batteries, non-essential, and the essential side first before it will export, okay? And then your CT offset, the reason we put this in here, and it's in watts, okay? The CTs, these CTs here, the CT, where is it? This one that we supply with a machine, we do not manufacture it. It's a third-party supplier. We can't control the accuracy of the CT. So if you connect CT to your machine and you don't want to export, but you notice that there's a variance, or it's still, there's a small variance, like maybe 50 watts or 100 watts, it's still pushing out. It simply means that the CT is under reading. Then you can offset it here. So in other words, if you want to stop, if your CT is pushing out power at maybe 50 watts, you've set it at 0, then you can set a negative value here. You'll go negative 60 and set. It simply means that when you're generating PV power, it will always retain or pull in 60 watts from the grid to make sure that the CT doesn't export to the grid by mistake. Okay, and then if you're doing the settings on your LTD, you're going to go through up to setting number 23. You'll see here it says CT set, and you can enable or disable it here. All right. I'm very excited to see the new Gen 6 LXPs come out, because they're coming out with a screen like this. It'll just be a color screen. All right, so that's coming to point number 9, which is the neutral potential earth bond introduction. There are some of you who are the engineers, we're certifying engineers, and where you need to know about the neutral earth bond. The neutral earth bond, as you know, with SANS code, any generator, any power generator that is connected, that puts out AC power that's connected to your house must have a neutral earth bond, because the supply that we get from utility or from the grid in a typical setup is bonded. So we might have TNC or TNS, but typically we have TNC here, which is earth and neutral is combined. So your feed from the grid is normally bonded from the transformer to the house, and you'll know that when you measure if you measure voltage on the incoming grid between neutral and earth, you should get 0 volts. Okay, if there's voltage there, then it simply means that the neutral earth bonding has been compromised, and you need to notify the utility supplier. In an off-grid situation, think about this now. If the power coming in from the grid is bonded and it's bypassing through the inverter, then obviously it's bonded. But if the grid should be cut, or load shedding or maintenance, and the power supply to the inverter from the grid is cut, then we put out a pure sine wave, which is not bonded. Okay, so in the old SNA 5s, we had to fit a external relay, or you had to do bonding on the AC out. But now with the new machines, we have installed a neutral potential earth bond relay, and you can enable that on the settings page. And if you enable it, simply what it will do is when the grid is on, it bypasses the power through, and there's no bond because it assumes that the bond is good. But when there is an off-grid situation, either when the grid is cut or you are installing your inverter in an off-grid situation, you will then enable the neutral earth bond, and that relay will engage. It'll bond neutral and earth on the EPS output, and that should give you 0 volts between neutral and earth. And the potential, and the reason why we do that is there's, if in a 230 volt installation, you should have about 115 volts floating there, and that could be dangerous for your consumer. You get a nasty little shock. Okay, but then we're going to look at this obviously just goes, it explains exactly what I've been talking about, and it's a safety protection, right? It ensures that the device's casing is safe during faults. There's a very, very low impedance fault current path, which then allows, in the case of a short circuit, it will allow a quick return to your residual current device. Okay. And then remember, I told you that in the settings, you can hear where it says protection setting, and that you will find this particular page here showing you our new web interface. Okay, so protection setting is neutral earth bond. You can enable it, and you're going to enable it fully if you want it. So we give you the option to enable or disable, but you've got to do it yourself as an installer. All right, and then parallel connection. The SNA 6 supports parallel connection from 2 up to 16. Obviously, 1 is 1, but paralleling, you'll go from 2. You can do a maximum of 16 units in parallel, and supports both single-phase and 3-phase parallel configuration. And then, as I mentioned earlier, the 3-phase parallel configurations can be unbalanced, which means you can have 1 machine on phase 1, 3 machines on phase 2, and 1 on phase 3. We've got many applications like that. They work well, and our engineers have done a lot of work on maximizing the logic for doing installations like this. Okay, here, this drawing looks quite imposing, but it's not really. This is just 3 inverters connected in parallel to form a single-phase inverter system. Okay. So here you have inverter 1, here you have inverter 2, there's inverter 3, and here is a shared battery bank, right? And then you have your PV, and here I see Kathy's put in blue. Remind you guys, you cannot share PV input anytime, okay? Batteries you can share across a common DC bus, but PV cannot be shared under no circumstances. Right? Don't try it. It's a dumb idea. So here you can see each inverter's got its own PV string. And then here's the combiner boxes. So the outputs are combined here. It's a detailed diagram. I'm not going to go through it. You guys are clever enough to understand it. And like I said, our material is available to anyone who requests it. Okay, and then the next one, we're going to have a look at the three-phase system. Exactly the same. PV cannot be shared. Here we've got a shared battery bank in a three-phase parallel. Okay, shared battery bank, we spoke about it. If one phase is idling, the other two have access to the full battery bank. No PV sharing, and then obviously your output is shared. Remember, in three-phase, the neutral is common. Okay, neutral is common among all of the phases because we're putting out a star configuration. If you measure with how you will know on a three-phase installation that you've got a good three-phase, if you take your multimeter and you measure between the inverter 1 live and inverter 2 live, you should get 400 volts. Between 3, you should get 400 between live and live, and 400 between 1 and 3, you should get 400, and then live to neutral is 230. Any live to neutral will give you 230, and live to live or phase to phase is 400. And that's our system output in off-grid mode. In on-grid, it'll obviously do exactly what the grid is doing, so that will fluctuate. But in pure sine wave, it'll be 400. All right, guys, that brings us to the end of today's session. Let's have a look. See, just after 11, done well. I'm going to go to the question section and just see if there are any questions that have been posed in the chats. Let's go to questions and answers. All right, so Mario wants to know, is it not possible to install 5 kilowatt in one input and 3 kilowatt in another? No. I'm assuming, Mario, I'm assuming you're asking about the PV. No. You cannot do that. Even though your combined strings total 8 kilowatts, you cannot exceed 4 kilowatts on any input. So unfortunately, you're going to, this 5, you're going to have to reduce to a 4 or do something, but you cannot do that. It's going to damage the MPPT. Okay, Excel Yoga says, I have a PV system consisting of 12 PV modules of 580. Okay. The system configuration is 6 modules connected in series, then connected in parallel to form one string to enter the DC protection box. Is it possible if the DC protection box output is made into 2 strings again and enters the 2 MPPTs in the LuxpowerTek inverter? Will the current from the one string of the inverter modules in parallel be divided into 2 if the output of the DC protection box is meant to? Okay, I understand your question. Basically, what Excel is asking here is, he's got 580, so 580 times 12 is, come on now, 580 times 12 is 6.9 kilowatts, right? So your maximum input there is 6.9 kilowatts. He's got 2 of 6. So that is 580 times 6 is 3.4. Then he's paralleled them on the roof, brought them down, and split it again and gone into like to the inputs. So let's have a look. See there. That means your output on the bottom will be. You don't say what your current is because you've left out the current here. It will work. If the current is split, but I need to confirm that. So I'm going to take, if Excel, if you can maybe reach out to me and just give me the other data that we're missing there, we'll be able to give you an answer on that one. Else, greetings, I'm using a 5 kilowatt SNA and I normally have a challenge of it tripping once the load reaches 4 kilowatts. What could be the problem? Okay, so your EPS overload will trip. Remember, if there is not enough PV, or the battery is insufficient, or the BMS output current is limited, but definitely not on the inverter side will it trip. And I'll tell you why. We've tested the 5 kilowatt SNA on battery. We've run it right up to 6.2 kilowatts continuous for a short, I mean, when I say continuous, it was probably up to 2 minutes. before we shut it down. But we know that if you have the right size battery, it will handle it, as well as the PV. So my recommendation to you is have a look at your your battery and see if you have a discharge current limit. If the discharge current limit is 4,000 divided by, let's work on 48. If the discharge current limit is 83 amps on 48 volts, or 80 amps on 50 volts, or 76 amps on 52 volts, then you're going to get an EPS overload, because the battery will simply not hold. But Mau 32, check the limit of your battery and break also, of course. Else, meaning I might have to increase the settings. Okay, I'm not sure what that refers to. It probably refers to, oh yes. Oh, so that refers to the guy with the battery. You have to have a look at your AC output. You might have a limit. You either have a discharge limit on your settings or a BMS discharge limit. Have a look at that. If you're not really sure about it, then you can ask us for assistance through the WhatsApp channel. I see Mau is answering some questions here. Thank you, Mau. Levan, okay, he's been answered. I think we've missed it, but is the smart load function available on the SNA 5000 with the latest firmware? Not yet. Okay. The reason why the smart load function is not available yet is because the topology of the 5 kilowatt, the older version, differs a little bit in that it doesn't have a CT on the Gen port, which for us is critical. So yeah, so the old SNA, this feature won't be available. SNA 6 will be a better option than if Flux become available. That's correct. Thank you, Mau. Come back. Okay, thank you everybody for joining the online training. I think we are going to be stopping this in a second, but before we go, I just want to say thank you everybody for joining us today. It's been fantastic hosting all of you. I think we've got 51 participants. Kathy, who manages our marketing and putting all of this together, she's recording the session, so the session is available on request. So number one, thank you everybody for joining. Number two, thank you for your support. We at Luxpower, we value your support. It makes just a great community. It makes a great company. Your input is always valued because it allows our R&D department to continuously upgrade and improve our hardware. It's cold and it's wet out there, guys. Be safe, and remember the key points of today. Make sure that your installations meet the requirements as laid out in the training session, and we look forward to our next training session with you. Peace.